Hello, Mr. Riley, right?
Maybe.
Just imagine we have the 3 cups.
Yeah. What about them?
So we have 3 cups, and this one is cold for cold water, this one is for warm water, and this one for hot water.
I take the warm water or cold. Depends.
So,
I think they
Yeah.
all have nothing in it.
yeah, okay, that's a good point. So we have some amount of water for each cup, right? Each cup. So for example, we know exactly, like we have 2 liters. Yeah, 2 liters.
How
And-
big is that thing?
Good
Because
question.
Because that's only 2 liters.
Yeah, you can think of it unlimited, okay? I'm just saying, unlimited cup. Unlimited capacity. And here,
yeah, but
three-
there's a hole in 2 of them.
Okay, okay.
There's a
And
hole
here-
in 2 of them.
That's 1. Okay,
There's
so
a
here,
hole in two
here
of
is the rule,
them.
okay? So for every second, I can drink, for example, I can drink.
You have unlimited water to drink.
No, but you're given the numbers, like for example, like 2 liters of cold water,
Yeah, but
3 liters of warm water, and 1 liter of hot water, okay?
Maybe.
So for every second, I can drink, just imagine I have
You have
an
to-
unlimited big tummy, right? For every second, I can drink 1 liter of 2 different types. Okay?
Oh my!
I can drink for every second, right? For 1 second, I can drink 1 liter of 2 different types.
Do you
I-
have to?
You listen out, right? Different type, yes. Or I can drink 1 liter of one type.
But do you have to drink something?
Yes, good question. Because my question is, what's the minimum number of seconds I need to finish or drinking of water? For example, in this case, 2,
3.
3, 1.
3.
How many seconds?
3.
Yes, why?
Because
If you take 3,
Because-
you could take 1. You could do 3 subtract 1 so that's 2, and then 2 subtract 2 is 0. 2 seconds.
6 divided by 2 is 3.
It's 3, yes, it's 3 seconds. Okay, let me get another example. How about 3, 3, 5? How many seconds?
So there is
We can simulate this process. So, okay, in this case, what's the strategy? First of all, it doesn't matter which one is hot, which one is cold, right? Am I right? The type of water doesn't matter, am I right? The most important thing is that the numbers, right? Am I right?
8.
How many seconds
No,
for this
no,
one?
not 8. Not 8. Oh, wait, what? Wait.
Why this
Wait,
is
what?
3?
6.
6.
I'll just, I don't know.
How do you come up with 6?
I just get up with 6. 1, 2,
6.5.
4, 5, 6.
6?
Yeah, because I just look at it like brute force.
Yeah,
Okay.
it's, I think the
Take
answer
one
is 6.
from-
Yes?
Take
Yeah?
So that's 2 and 4. Number 1, 3. Number 0, 2. And then since this is the maximum,
Yeah.
then eventually I have to do
Okay.
this. And then yeah.
So, what's the strategy? What's the strategy? So you just pick 2 numbers and just finish all these 2 at once.
Do they have to be 3?
What do you mean 3? 3, yeah, there are 3 types of water.
And
Yeah, your strategy, why you pick 3 and 5? Why you not drinking 3 and 3?
because 3 and 5, if you pick 3 and 3, then eventually both of these will be gone, and then you'll be left by just doing
Yeah.
1 for each.
And then this is not optimal
Yeah.
because that will be
Yeah.
8, right?
Yeah, because so you do these 2, so when because since there's 3, if you do this one, then when this one is gone and this one is almost gone, then you can use it. Then you can just drink one.
Okay, so your approach here it seems to work because look, 5, 4, 3, right? Is still the maximum, right? Does it make sense? Even if you're reducing 4, still the maximum, 3 to the maximum. So yes, we want to drink the one. Definitely, we want to drink the one with the most water first. Am I right? Does it make sense? If like 2, 5, 100, right? We want to reduce this first, right? We want to look at this first. We want to reduce the one with the most water. Does it make sense? Because Because when we reduce it, we might be able to reduce some other parts at the same time. Make sense? But if we're reducing these two, the smaller amounts,
And then you have to
these
keep
keeps,
that.
yeah.
And then you have to do 100 of that. Add those.
That's right, yes. The total is not decreasing, right? Makes sense. If I do this, what happens? I still have to at least do this at least 100 times, right? Because
No.
this is not decrement. Make sense?
Yes.
Okay, so let's try this one. Try one more example, okay?
Try 5, 4, 4.
No, just 3, yeah. 5, 7,
9, 2.
5, 7, 6. So it'll be
What?
5, 6, 5. We can do 6 and
6.
5, right? Okay.
Is it 666?
5, 5, 4. Okay,
Wait,
so
wait.
now at this point, 5 and 4, right? 5, 4, 3. Okay, at this point, we're not doing 4 and 3, we do this 4 and 5. Make sense?
Yeah.
Okay, and then we do this 4, 3, 3, and 3, 2, 3, and
And 3 and 3.
3 and 3, not 2, right? Yeah?
And then
2, 2, 2, right? And then 1, 1, 2, and then
2,
1, 0, 1,
1,
and then
and 0.
0, 0, 0. How many? 1, 2,
Okay,
3, 4, 5, 6, 7, 8, 9.
No.
9 times. So,
That's 8.
okay, 9 times. Okay, so
Wait, 1, 2, 3. 1,
Yeah.
2, 3, 4, 5, 6, 7, 8.
9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 times. Okay. So
That's
we can do
8.
this simulation, right? We can do this simulation. Make sense? The idea is that we want to reduce the one with the most and the second most.
Yes.
Okay, so just imagine if this 2, 3, a million, how many times?
A million.
Okay.
A million.
10, 20, 100, how many times? Okay, I'm going to give a few examples, okay? 3, 5, 20, how many times?
20.
100, 200, 1,000, how many times?
1,000.
Okay, so what are these in common?
So,
What are these in common?
Don't say the biggest
so
one.
well, you choose the biggest one if the smallest one is equal or less than the biggest one.
All equal or less than, what do you mean? I mean, yeah, what are these in common?
Okay, so these two is smaller than this.
These two what are smaller than this?
Sum.
The sum, yes, the sum, yes. Because these two, the two smallest amounts added up together is smaller than the biggest, always reduce the biggest one, right? And eventually this will become 0, alright? And this is the number of the seconds. Make sense? This is one way, okay. How about if not? If this is the case, 5, 6, 7. So the answer is not 7, right? Yeah?
Yeah. You just do the math.
The smaller one added up together is bigger than 7. We don't have enough max amount to reduce other twos to 0, okay?
Yeah.
Okay, so in this case, what's the answer?
If it's the sum is equal or less, it can be equal because the 2 liters, 3 liters, 1 liter is 3.
Yes. Okay. Okay, so let's look at a
Yeah,
simple
yeah.
example. Okay. 2, 2, 2. How many times? Look, 2 and 2
One.
plus is bigger than
Is it
3.
3?
Yes,
One.
look.
I did the timer one out. I
Okay.
look at this.
Yeah.
1.
Okay, okay. Okay, how about 3, 3, 3? How many times?
4. No. 3. No.
So what are we doing? I mean,
5.
okay.
Aww.
Look, previously, yeah, if the smallest one, A plus B, is smaller or equal than C.
5.
This one?
5.
Yes, 5. But I can get the number immediately, right? I get 10, 11, 12. I know what's the answer.
What is it?
I know what's the answer.
Oh, I know as well. 12.
No, it's 17. Okay, so this is 17. Okay, another example. 20, 21, 22. What's the answer? This answer is
Is it 30?
32.
Oh.
Okay, I give you a hint. What's the optimum situation? in 1 second I can drink.
2.
Yes, I can drink 2. Okay. So if this is the case, I can drink. All I have to do is add it up together, divided by 2, and do the sealing. Right? Do the sealing. In case there's only 1 odd left, I have to drink that. Make sense?
What's ceiling?
Seal function. 3.5 sealing is 4.
Alright.
3.9 sealing is 4. It's
What-
the
what-
next smallest number, that bigger than this. That's sealing. Right?
About 3.
Right? 3 is 3. Okay, that's a good question. Okay, and floor. Floor is the opposite, right? 3.9, the floor
3.
is 3. Okay, just imagine this number, right? The ceiling is next smallest number bigger than the current. Floor is the
Next.
last biggest number smaller than current. Okay, the opposite. Okay, makes sense. Because for the ultimate, I can add it up together. Every time I can drink 2. And the leftover, which is only 1 left, I still have to take 1 second to drink it. Make sense? Yeah. For example, like this one, 2, 2, 2, 1, 1, 2. Okay.
So that's 2.
And look, I can always take 2, right? 1, 0, 1, right? Always take 2, right? 0, 0. Okay. How about 2, 2, 3, right? Look, if it's 2, 2, 3, what happened? Why we need to add 1? 2, 1, 2, right? Here. 1, 1, 1, right? Here. 0, 0, 1. Okay, so this is the level I still have to add 1, right? So how many?
4.
2 plus 2 plus 3. 7. 7
Seven.
divided by.
2 is 4 since it
Yeah,
goes
yeah.
to the bigger one.
Yeah. Okay, so 7 divided by 2. This is 3.5. But I have a level where I use the sealing. So 1, 2, 3, 4. Make sense? Yes? Everything makes sense. Ryan, does it make sense now?
Yeah.
Okay. 5, 6, 7. How many?
5, 6, 7, 8.
How many seconds?
11, 18.
9. Yes, good. 5, 6, 10. How many seconds?
21, 11.
21, 11. Yeah? Okay. 15. How many seconds?
Is 26.
Are you
13.
sure? Are you sure? What's the previous check? What's the previous situation?
Is it 3? No.
5, 6, 15. Come on, what's the one we talk
15.
about? How many seconds we need to finish this? You talk about that.
Oh, 15.
Yeah, 15. Okay, that's a trick. Okay, now I'm going to write the code. I will write the 3 code, and then you tell me which one is better, and then you tell me what are those. Okay. Answer equals 0. Where max A amount, right, is bigger than 0, A dot sort A minus 1, A minus 1 minus equal 1, A minus 2 minus equals 1, return answer, answer plus equal 1. Okay, I'm going to write another one. A dot sort if A minus 1, if A0 plus A1 bigger than equal than A2, then we return smaller or equal than A2, then we return A2. Otherwise, we return sum of A divided by 2, and we do the sealing function. Alternatively, we can do sum A plus 1 divided by 2. This is also okay. Sum A plus 1 divided by 2. Okay? Or we can do this max of, we want to return the max of max A, or sum A plus 1 divided by 2. Divided by 2, okay? This is also okay.
What's this?
It's a cooling chip put on a CPU.
What's the chip?
Okay.
It looks a bit dry. Do you need some ketchup?
Sealing A sum A divided by 2. This is the same as sum A plus 1 divided by 2. Okay, these are the same. Okay, so which one is better? Look, this one, simulation. Why max A is bigger than 0? what's max A? We want to find out. Okay, so if max A is bigger than 0, it means we still have water to drink. A dot salt. We want to sort the remaining water in ascending order. A minus 1 minus 1. A minus 2 minus 1. Okay, so we want to drink the bigger two, the cups from the bigger two. Right? And answer. It takes 1 second. Make sense?
Yes.
Okay, this simulation, what's the time complexity for this one? If you look at this. O max A, right? The sorting usually is O and log n, right? But A, only 3 numbers. Sorting 3 numbers, what's the time complexity? I have 3 numbers. Sorting it, putting it in order, what's the time complexity?
1.
O1. Well, yeah. You can just do this. If A bigger than B and bigger than C, put the A first. Else, if just a bunch of if else, right? Okay. This is O1. Minus 1, O1, answer equal 1. So basically, the max A, right? Okay, max A dominates here. It takes max A loops. This is there's a loop, O max A. Remember, the max A, the biggest number could be very big, right? If I put the number 1,000,000 there, then it takes 1,000,000 iterations. Am I right? Okay? The second one, right? Look, we sort it first. A dot sort. What's the time complexity? In this case, we're sorting 3 numbers.
1.
O1, okay? Then check. If the smallest two, A0 and 1, because I sorted. If the first 2 numbers added up together, smaller than the third cup, this could be 1,000,000. So the answer is
Then A.
2,
Yeah,
which is the biggest one. Otherwise, the answer is that we will be able to take 2 cups at the same time. The time to drink all of it is divided by 2. But remember, the last cup we need to take another second, so it's stealing. Okay, and then this is basically the same as. Look, this is basically the same as what? We want to check the maximum, right? We want to check the maximum, which, the maximum cup, number of seconds, and then do this, right? This is the same thing. There are 3 approaches. Which one is better? Eric, right? Which one is better?
The last one.
These 2 are equally better, okay? They are all 1, right? All 1 constant. This one is the simulation, okay?
Equally the best.
Equally the best. Okay, so what have you learned today? If you want to describe this, to mommy, right? If you want to teach mommy tonight, so can you just imagine I'm mommy?
Okay.
Okay. So what have you learned? What have you learned from daddy earlier today?
So we have these 3 cups, or it doesn't matter, and they each have like water in it, and then every second you drink lots of, like 1 liter.
1 liter of. I can drink 1 liter of one type,
Yeah,
or 1 liter
I
of
can't
2
imagine-
types, 2 different types.
I can't imagine your mummy. It's unreal.
Okay. The key thing is that I can't drink 2 liters of same types. For 1 type of water, it needs that seconds to reduce it. Am I right? Yes? Okay. So if a cup has 10 liters, the answer is at least 10, right? Am I right? Because it needs the 10 seconds to reduce it. Make sense?
So to figure it out, so we like sort it, since there's only 3 cups, then there we are 1. So if the 2 smallest numbers sum is smaller or equal than the biggest number, then you return the biggest number, because, well, yeah. And oh yeah, so you can have like 3 numbers, and then you times you give the sum of all of the cups, and then you divide it by 2, because that's the max, and ceiling as well, which is basically rounding up to the integer, yeah. And then you divide it by 2, because that's the maximum you can drink.
Yeah, because every time I take 2, right? So yeah, the number of seconds is always half. Right? Okay, that's very good. -1, we sorted -1 is the largest cup. -2 is the second largest cup. Right? And we take 1 more seconds to drink. And every time we sort it, right? Every time we just rearrange these 3 cups. And we drink the most cup and the second most cup. Okay? Until the max A is 0, means that all the cups are drunk. Okay? That's it for today. Bye bye.
Bye.
Bye bye.